Okay, so let's continue with the chapter 9 topics. We have started this last time, and if you recall, polymorphism means, the name indicates that you have for the same method call, for the same object name, you have a different meaning. So you have a polymorphic reference for a given variable or invocation. So in this case, we have, let's say, an object that's given with variable object, and then it has a certain doIt method. Its meaning, the inherent meaning of the doIt method will be identified at compile time. This is called dynamic binding or late binding, and we're going to first see what kind of object this refers to, and then based on that we are going to execute the corresponding method as we implement. As we said, the term indicates that having many forms. So an object can refer to different things throughout the execution of an application. So if you look into the example here, occupation job, if you have a reference to this job, it can point to any object that is compatible with the occupation type. If you have an inherited classes that are part of occupation, then you can use those for referring to the same object, or creating an object that is referred by the same variable. That's possible to do so. So you have to consider polymorphic execution, and based on the object it points to, you have to identify what actually is going to be executed. In this case, if you look into the example we have seen, you have a holiday class, which is a parent class, and then a Christmas class, which is the child class. And if both of them has a celebrate method, and then you have such a call, holiday day, such that day object is going to be a holiday type day, and then you create the object such that it is one of the child's objects. So it's going to be a child object, in this case a Christmas object. So whenever you call the celebrate method, which method is it going to execute? If I call the celebrate, if both of them has the celebrate method, it's going to use the Christmas's celebrate method, which is basically because you're pointing to that object, a Christmas object, and you have to use the corresponding method for that child in order to execute it correctly. So we saw that this is polymorphism, and the day.celebrate call will change meaning as you run your code. Such as, for example, if I have a declaration that indicates, let's say I have holiday day 1 equals new, and then holiday, and I call day 1 dot celebrate, and then I have another initialized object for day 1. Day 1 equals new Christmas. Let's say this is the same variable that I'm using for reference, and then I call again day 1 dot celebrate. In the first celebrate call, it is going to basically use the holiday object, which is actually what it is referring to. That method, the celebrate method for day 1, is going to be holidays method. However, in this case, the same day 1 is going to refer to a different celebrate method, which is the Christmas's celebrate method, and this indicates the polymorphism. So as you go in the execution of the code, the meaning of the same call in terms of the literally identified by the same variable and same method name means two different things. So that's what we mean by polymorphism. And if you recall, we had this example where you have an inheritance. This is also useful for your exam. So if you're not following, let's say you have a staff member, which is the base abstract class, and then you have a volunteer and an employee, which are child classes of the base class, which both of them extend the staff member, and then you have another extension to employee, executive, and hourly. So if you recall, we have talked about this example a little bit, and let me go over that. employee executive, and then I have firm, hourly, and staff member, and then volunteer. So these were all classes that's part of this. So if you look into the staff member.java, this is an abstract class. So as you see, abstract public class staff member, public abstract class staff member. The staff member could also be used, and you have the protected, instance variables. Why are these protected? Basically, to be able to enable the child to access these, right? And then you have a constructor for the abstract class where you have string, name, address, and phone. Basically initiates the 3 instance arguments, instance variables. And then you have the toString method, which basically prints the name, address, and phone. And then another third method, which is, an abstract method, public abstract double pay, which is not implemented within this abstract class. So whoever, extends this class needs to implement, extend the implement the abstract method pay in order to be able to be a concrete method, a non-abstract method, right? So if you recall the figure, staff member is an abstract class, so we have a volunteer and an employee that is extended by these 2 classes. And if you go into the volunteer, you see that public class volunteer extends staff member, and you have the constructor. What the first line of the constructor is to construct the parent class, which in this case is going to be called by super and the 3 arguments we mentioned before. And then you have the pay method, which again, in order not to be an abstract class, you have to implement the pay method, which was the only abstract method. You implement it by public double pay and then just return 0. And if you look into the employee.java, it's again, extending the staff member. In this case, we have public class employee extends staff member, and you have additional instance variables that are, only part of this child class rather than the parent class. And again, they are used as protected since it also has children, right? If you recall the diagram, employee has these executive and hourly as its children, so you define them as protected. Right? And then you have your constructor. The first line it is going to use is the super, which is basically going to create the abstract staff member class object, right? And then it initializes the remaining arguments to the corresponding instance variables. And the toString method, what happens to toString method here? It's basically overriding the parent toString method, which was the staff member toString method, so it's overriding that. And you have the double pay method, which is again, executing the abstract method of the staff member. It just returns the pay rate of the instance variable. And if you look into the subclasses of employee, you see that there's executive and hourly. And if you look into the executive example, you have public class executive extends employee, so it's basically extending employee. And in this case, I have a private bonus variable. Why is it private? It doesn't have any child, so it doesn't need to define them as protected. However, if it had any children, then you would have defined this as a protected. However, since it doesn't have any children, it's private. And the executive is going to, when you have the constructor for the executive, it's going to basically call the constructor for employee, which is going to call the constructor for staff member. Okay, so it's going hierarchically all the way to the top. So this super calls the employee. This super calls the employee super such that it creates the employee object, and then you create the staff member portion of the same object so that it goes all the way to the root of the whole class hierarchy. And if you look into the award bonus, this is just a separate method that is implemented only in the child, the executive. So it's added there. And then the pay method, which is basically overriding the parent's pay method, which was the employee. Employee's pay method will no longer be valid here. However, its own pay method will be implemented. And if you look into the hourly, you see that hourly extends the employee, so it's again extending the employee, child of employee. And it has private instance variable, since it's again, it doesn't have any children. And this constructor will first call the constructor of the parent, and then initialize this hours worked. And add hours is specific method, and then it has the pay method that's overriding the employee class. And then also you have the toString method, which is again overriding the method of the base class of the employee. And if you look into the staff, it's basically, it's basically a class that creates employee objects, nothing more than that. So it just creates 6 staff members. If you look into the staff list, it's basically creating the new staff member 6. So it's going to have an array that's going to hold 6 staff members, and then it creates staff list 0 new executive. So although all of them are staff members, you can initialize it to a child of the base class, which is the staff member. So if you look into here, staff member is the base class. You create the object references to point to this. However, when you create the object, you actually have these pointers to point one of the children, either employee, volunteer, executive, or hourly. So if you look into this, you see that staff list 0, new executive, staff list 1, new employee, and so on. You have staff list 3, new hourly, staff list 4, new volunteer. So this is where polymorphism come into play. So you can use variables to refer to a child of the object in order to create polymorphism. And whenever I call these methods, I indicate that although it's a staff member, I know that it's an hourly object, so I mention this casting such that it's an hourly object which is going to perform the add hours method, and then similarly award bonus will be executive's method. And when the payday comes, you have the payday that's going to call the pay method of the corresponding object. Although it tells you that staff list count.pay, it is going to call the corresponding pay method of the object that it is referring to. If it's an employee, it will call employee.pay. If it's a hourly, it will call the pay method of the hourly object. If it's an executive, it will select whatever the corresponding pay method is. Although all of them are staff members. Okay? It doesn't know it at compile time, so you have to indicate that it's an hourly. At runtime, it is going to know, but at compile time, it doesn't know that it's an hourly object. So you have to use casting in order to indicate that this add hours is specific to hourly objects. So it needs to know that this is an hourly object. Then you lost, if you erase that part, then you will lose the code actually. So that's going to be a totally different code. You don't need to put any cast on pay because all of them are implementing pay anyway. Okay? However, for volunteer or for hourly, you only have add hours for hourly, or you only have award bonus for only executives. You don't have the same method for the remaining parts of the class hierarchy. That's the main reason. Okay? Award bonus is only specific to, if you look into the executive, you see that this is only part of this executive, nothing else. No other class has this method. However, the pay method that's given here without any casting, pay method is valid for all of the objects because it's part of the main abstract class that we defined at the top. So it's basically going to print all the staff members as we did before, so I'm not going to print all of them one after the other one. So this is the example we just saw. I'd like to do another example, which is not within this, slide set. So let's say you have another hierarchy which is composed of an employee, salaried employee, hourly employee, commission employee, base plus commission employee. This is from a separate book, so I wanted to show this as an example also. If you look into the employee, this is an abstract class, which is the top of the class. Let me see if there's the figure. No. So it's basically something like this. You have the employee class, which is an abstract class. And then you have the classes that extend this class, such as the salaried employee. And also you have the hourly employee. And also you have the commission employee. So these work by hours, these work as a salary. However, these work with the commission according to the number of things that are sold, or number of revenue, or the value of the revenues that the company makes, and so on and so forth. And it also has a commission employee, has a child, which is base plus commission employee. So if somebody tells you, hey, I have an employee abstract class with features first name, last name, social security number, and then another subclass of this in this hierarchy, salaried employee with an additional weekly salary, and this is going to have first name, last name, SSN, and weekly salary as its instance variables. And then you have an hourly employee with the certain features, such as if the number of hours is less than 40, it's just basically wage times hours. For extended hours, the person gets 50% additional, right? So that's basically the calculation shown here. And then it also has first name, last name, SSN, the wage, and then hours worked, indicated by hours. And then you have commission employee, which has commission rate times the gross sales of the company, and commission employee, first name, last name, SSN, gross sales, commission rate. And you have the commission rate times gross salary plus a base. So they are given a base salary to start with, and then on top of that, they earn additional money as the company makes more profit. So that's the basic idea on this last one. And they have, again, first name, last name, SSN, gross sales, commission rate, and the base salary. So these are given as a table. So if you wanted to, if I wanted you to write the code for this one, how would you start with? So you're given this hierarchy. This tells you the hierarchy, and also it gives you the specifications of the classes that you need to write. So the first thing that you would like to do is to start with the employee abstract class and write it, right? So it's going to basically have the common features that are part of all the classes that are subclasses of this main class. So in this case, since it's common with first name, last name, and SSN, you will probably have those as part of the abstract, such that it keeps track of those. And then for the remaining things, you add as you go, as you grow the objects of the class hierarchy. So and then for things that are needed, such as the pay rate and others, you will implement the different method calls for different properties of the object that you're defining. So in this case, if you look into public abstract class employee, this is the first class. That's the top class that we have shown here in the hierarchy. And you're going to have the private string first name, private string last name, private string social security number, and then public employee string first, string last, and string SSN. And you have the constructor that is constructing the employee object as an abstract class. So as you see, you declare the abstract class at the beginning of the whole thing. Actually, this was supposed to stop there in my computer, but it doesn't stop here. For some reason, it just vanishes. So the common attributes are listed here, as you have seen with this small, time frame. It has all the, arguments initialized, and then you have the common methods that are again part of the employee class. What are the common methods? You have the set first name, get first name, set last name, get last name are the common methods. And then also you have the set social security number, get social security number, toString, and also you have an abstract method which is earnings, which is basically going to be implemented for individual employee types according to their calculation mechanisms. So as you see, it has its toString and all the necessary methods implemented within this class. So you don't need to define all those in the subclasses implemented from this class. Any question? And this is the only abstract method which is left as abstract. If I didn't have this abstract method, it would be a concrete class anyway, right? So abstract method indicates that it's going to be an abstract class. So when you look into the salaried employee, so we have the salaried employee, which is going to extend employee, and it's going to have its weekly salary as its private instance variable. If you needed to access this in the children, you could have defined this as protected. However, it's not needed in the children, and that's why it's defined as private, right? In the previous example, if you remember, we defined these instance variables as protected. However, here we're using them as private. And the one other reason is because you already implement a get salary, set salary methods anyway. So you don't need to enable them accessing these private variables. And if you look into the constructor, again, same thing. You have this public salaried employee with the arguments, and you have the super reference to indicate the employee class first, created, constructed, and then you set the weekly salary to salary, which is basically a void method to set the instance variables. So if you look into here, basically it's checking for negativity. If it is not less than 0, it will set it to salary. Otherwise, it will set it to 0. You remember this comparator operator, right? So it compares salary with 0. If it is true, if it is less than 0, set it to 0 if it's a negative value. Otherwise, if it's false, then go and assign it to salary. Okay? So this is a child class extending employee. And then you have the super class, a super reference to indicate you're first creating the parent object and then continuing with the next one. And you have the set week salary to set the salary. Obviously, you could have just set it here immediately. However, since it's already implemented in terms of the conditions, it's just calling it to to perform this computation. And then, if you look into this part, we have the salary get weekly salary. So we have the set weekly salary and then get weekly salary, which returns the value. And you have the earnings, which is implemented since this was an abstract class. Since this was an abstract class, where implementing the abstract method, which is an earnings, and it's just basically the weekly salary of the person for salaried employees. So that's given as a specification. And then the toString method is also, also overridden. So if you look into here, the toString method indicates salaried employee's salary. And again, if you look into this call, it calls the parent's toString method before printing the rest of the line. Okay, so this is also important. If you want to call, in your toString method, if you want to call the parent, you would call super.toString to indicate that you would like to execute it before printing this remaining part of the child object. Any question? No? Okay. So earnings override and implement the abstract method, and the toString method is also overridden, as we see, and then the super indicates you're calling the parent's toString method in your implementation. And then hourly employee.java, which is basically again extending the employee class, and it has again its private variables, wage and hours. And if you look into the constructor, we again have the same thing, public hourly employee with the super and its set wage and set hours. Again, you could have set them directly, but the methods are already implemented. It's calling those methods. Set wage, again, it's checking whether the negative value is shown on the hourly wage. If it is so, it assigns 0. Otherwise, it sets it to hourly wage. And for get wage, it basically returns it. Superclass is called, and then validation is done. Then you have the set hours and then get hours. Basically, again, if it is greater than 0 and hours worked is less than 168, hours worked is going to be equal to 0. So this is basically checking whether it is within the bounds of 0 and 168. So if it is not within these bounds, it sets it to 0. Otherwise, whatever that value hours worked is. And get hours, you have the public double earnings, which is computing the same thing. However, for the hourly employee, it's going to be implemented differently. Get hours if the number of hours is less than 40. Get wage times get hours, so that you multiply wage with hours. However, if the number of hours is greater than 40, it's going to multiply 40 by get wage for the first 40 hours. And then the remaining 40 hours, it's basically going to subtract 40 so that it gets, let's say, 50 hours. The additional hours, Messiah hours, are 10 hours, right? So it's going to multiply it with the 1.5. Additional 50% will be given for those hours. And then toString method is also modified here as well. So it calls the super.toString method of the parent's toString method, and in addition to that, it prints the hourly rate of the current employee and so on. Any question? The reason is, if you look into get wages, where's the get wage implementation? So if you look into the set wage method, as you see, there's a certain coding here which checks the bound conditions. So in order not to write it again over and over, it just calls the method and immediately assigns it. It could have done this here as well. It's no problem. In terms of accesses, although it's private, since it's own method, it can access it. So there's no problem. But the reason it's accessing the method is because there's some additional, constraint checking here before, assigning it. So it doesn't rewrite this same line again on that specific position. In that case, if the hourly wage is negative value, such as this case, it's going to be a negative result. Olur. So it's okay to write it directly as well, because you're right. Actually, since with the set wage, you're actually checking it, so it cannot have a value that is out of the range, which is already checked here. So you don't need to basically, call the method. You can directly write it here. It's okay. Okay. You're right. you don't, I thought was going to check for the conditions, but you're right, it doesn't need to check, since if the wage is set here, it should be non-negative value. So again, validates the hours, and then calls the overridden earnings method, and you have the toString method, again overridden as opposed to the parent class's method call. And if you look into the commission employee, it is going to again extend the employee. Same thing. You have the super call to create the parent object first for the constructor, and then it has the set commission rate, again the get commission rate, and you have the set gross sales and get gross sales, because gross sales was one of the instance variables of the class. So you set and get that parameter as well in this part of the code. And if you look into the earnings, this is again overriding the method by calculating the get commission rate times get gross sales. So it basically multiplies the commission rate with the gross sales and returns that as a result. And if you look into the toString method, it again calls the super method, the parent's toString method, to have a nice view of the output. So one thing to add here is the last part of the class, which is the base plus commission employee. Base plus commission employee extends commission employee, okay? In which case you have the additional base salary, which indicates the base salary, plus the gross sales times the rate, right? So that's what you're going to multiply and add to the base. In this case, you're first going to call the constructor for the super, which is the commission employee constructor, and then you will set the base salary. Again, you can set it immediately to the salary that is given by the by the argument, and it's going to call this method to set the base salary. And if you go into the next page, you see that get base salary is also shown here. And the next thing is public double earnings. This is basically again overridden. So this was the main abstract method here, and then we have implemented it, overridden it in the commission employee, and now we are overriding whatever is implemented with commission. And if you look into here, return get base salary, so you get the base salary plus whatever is calculated by super.earnings. Since super.earnings already calculates, if you go back to the super.earnings, so this is where earnings is calculated in the commission rate times gross sales. In the extended one, the method is implemented commission rate times gross sales plus the base salary. This is the only difference. So this part is already common in here, and you're just adding this onto whatever is presented here to implement the overall calculation. And if you look into that, it gets the base salary, which is the addition component here, the base salary, plus the super.earnings, which is going to give me the computation for commission rate plus the times the gross rate. And that's going to, give me the earnings for this specific employee. And if you look into the toString, it's basically going to, print things on the screen as we did before, and it uses the supers, the parents toString method also to print things on the screen.
Hocam süperi çağırmadan da şuradaki yaptığınız şekilde yazabiliriz değil mi? Commission rate çarpı gross rate.
Exactly. If you want to implement it directly using the current values at hand, you can do that too. So you could have explicitly write the whole calculation by yourself instead of calling this super.method to implement this part. It is going to call the commissions. Super.toString is going to call the commission, since it's super is commission employee. If you want to access the super, you can do that too. Super. And So we can access that too. Any question? You can access it with parentheses. If you put super and then parentheses and then dot and super dot, you can access it. So payroll systems test is the main, running class where you have the actual, payroll system. And here, as you see, you have the public static void main, and you create the object. Salaried employee, new salaried employee, hourly employee, new hourly employee, commission employee, new commission employee. They are just created as if they're own objects. So there's no difference in the name and the object creation. If you look at salaried employee and you create a salaried employee, it's an hourly employee and you create an hourly employee. It refers to a commission employee and you create a commission employee. So far there's no polymorphism seen in this application, right? So these are basically regular declarations and initializations. And then when you go on to the next part, you see that if you call these system out with system out printf and print things on the screen, you can print their earnings one after the other one. And then when you create an employee array, so this is where polymorphism comes into play. You have an employee array which is going to have 4 employees, and you create employee 0, salaried employee, employees 1, hourly employee, commission employee, and base plus commission employee created in the or assigned into the employees elements. So basically now, if you call for each one of them, if you call the system out print line current employee, it's going to basically call the corresponding employees objects, referring to the objects toString method, right? So whenever I call current employee, it's an iterator on the employee objects, right? Current employee is a type of an employee, and it iterates on the employees array, which has 4 elements here, and it's going to, whenever I call with system out println, it's going to basically call the toString method of each current employee, and for this one it's going to call the toString of the salaried employee. For this one it's going to call the hourly employee. For this one it's going to call commission employee. For this one base commission plus base plus commission employees toString methods. So that's where polymorphism comes into play, and each one uses the corresponding toString method. And also this is also important. So as you see, if current employee instance of base plus commission employee. So what does this indicate? Exactly as your friend said, this is basically checking if the current employee is of type this object, base plus commission employee. If it is so, you can use its features since it's already one of these objects. So not all of them will be able to go into this if, but only one of them, which is the last one, right? So it's basically the last one, which is this one, base plus commission employee, is going to be able to go into this if portion, and then it's going to update the base salary with a new salary as they have done here. Okay, so instance of indicates returns true or false based on the first object reference. If it is type of this class, then it returns true. Otherwise, it returns false. You can use getClass, but it's going to return an object to you. getClass returns an object. So, however, if you let's say if you want to use getClass, and then if you use getName, this is going to return you a string, and then you can compare it with the corresponding class name that you need to compare to. However, this is exactly as instance of. I mean, there's no difference. If it's an instance of this class, this is really useful if you need to identify what the type of the object and perform a certain task according to the type of the object or the reference. You need to use instance of. And if it's if it's an instance of, you're just basically downcasting it and then updating the salary based on that. However, if it is not base plus salary, then you won't be able to perform this part. And at the end, it just, as you see here, you print the class. If you look into here, employees j.getClass, so you get the class type and then get name. So it's going to basically print the class name, such as in this case, it will print hourly employee, salaried employee, or a commission employee, or the base plus commission employee. So it's going to print the name of the class. Get class, get name. So if you look into here, you see the execution of the whole thing, but you know, we don't need to go into details. But here is what I meant by the class names. Employee 0 is a salaried employee. This is the name of the class. So get class, get name will return you the class's name. Hourly employee, commission employee, and base plus commission employee will be printed for each of these employees in the array. Okay, any question? Any question? So we have, again, we can create a hierarchy using the interfaces. So let's say you have an interface payable, which is implemented by invoice and employee, and also you have a salaried employee, as we defined before. So if you want to do that, you can create such a hierarchy using the payable interface as well. Let me go over it. So this is the interface. Again, you have interface in your exam too. Public interface payable. So it just has one method, which is double get payment amount. So it calculates the payment and, you know, returns the double value as a result. And that's the basic implementation or basic description of this interface. And then, obviously, this is an abstract method. By default, they're all abstracts, if you recall, in the interface. And when you look into the implementation of invoice, public class invoice implements payable. So if you're going to implement this, you have the instance variables, and then the constructor, which is basically having the 4 instance variables as arguments. And then you have the set and get methods, set part number, and then get part number, set part description, get part description, set quantity, get quantity. All of these are the instance variables that are, you know, setters for getters. And set price per item and get price per item. And you have the toString method, which is basically the toString method. The key point here is the interface implementation, which is the get payment amount. Again, the same, you know, signatures here, appearing here, and it just returns the quantity times the price per item. So in the invoice, you need to know the quantity, how many of those things the person is requesting, and then the price per item value. So it will return the price times the number of items, will give you the payment amount. And if you look into the employee, again, it's implementing. One is, remember, one is invoice, the other one is employee. Both of them are implementing payable. This one also implements the payable, and it has 3 different, you know, totally different arguments, instance variables, and then you have the constructor. And if you look into the setters and getters, first name, last name, get last name, set last name, and then you have the social security set get, and you have the toString. And if you look into the payable method, get payment amount, you would like to, you know, define it as an abstract class and leave it for, you know, for future. And get payment method is not implemented here. And if you look into the salaried employee, remember, employee was an abstract class, right? That's why this method is not implemented here. Okay? So employee was an abstract class, and the salaried employee is a concrete class. That's why it has this additional instance variable, the constructor, set weekly salary, same as before. However, in addition to that, it now implements the public double get payment amount, which makes it a non-abstract, a concrete class now. Okay? So this implements the get payment amount, which will basically return the get weekly salary. So if you look at the hierarchy, it will be more clear. So let me show you the hierarchy again. So this was the hierarchy. This is the interface. Both of them implement the interface. However, this is also an abstract class which does not implement the interface's payable method, which is implemented by salaried employee. Okay? So that's why we didn't implement it here, however in the salaried employee. And then you need to implement it with all the two remaining ones as well. So this is showing the interface versus, abstract implementation in some way. Any question? Okay, good luck with the exams. I'll see you tonight.
Hocam bunları bize gönderebilir misiniz?